Hi everyone, Mrs. Nowakowski here. Earlier this unit we talked about solving square root equations like the first two review problems. So just wanted to go over and refresh your memory on how to do this. So you always start by isolating at least one of the radicals. When you look at number 1, you can actually isolate both, but if you notice that square root of 10x minus 1 is alone on one side of the equal sign, so we can say that that is isolated. Once you isolate, you want to try to cancel out the square root. So the best way to do that is to square both sides. When you square a square root, the square and the square root will cancel out, and you are only left with what's underneath. Now, just be careful when you are squaring the other side. You have that 3 in front of that square root, so you also have to square that 3. So 3 squared is 9. When you square the square root of 4x minus 3, you're left with 4x minus 3. And that 9 and that 4x minus 3 are getting multiplied together, so we can distribute. And now we can just take steps to solve for x. So I'm going to subtract the 10x over, so we're going to have 26x. I'm going to add the 27 over to the other side, so we have positive 26. And we're going to get that x is equal to 1. Please remember that when we are solving square root equations, we always need to check our answers because sometimes we will have an extraneous solution. So the way to check your answer is to go back to the original problem. When I say the original problem, that means really the problem that's typed on your page before you do anything to it. So don't use the equation after you square it. You want the original equation. So we're going to plug in the 1. So we have the square root of 10 times 1, which is 10 minus 1 has to equal 3 times the square root of 4 times 1, which is 4 minus 3. So we end up with the square root of 9 is equal to 3 times the square root of 1. Square root of 9 is 3 is equal to 3, and the square root of 1 is just 1. So we end up with 3 is equal to 3, which we know works. So 1 is a valid solution. So for number 2, I'm going to just do something a little bit differently to prep us for what we're about to do. Over the past few days, you've been learning about fractional exponents. So here we have the square root of x plus 2. Knowing that this is a square root and knowing what we know about the fractional exponents, we can actually rewrite this as x plus 2 to the 1/2 power. The only reason I am doing this is to show you that both of these equations mean the same thing. So when you have, whether you have the square root of x plus 2 or x plus 2 to the 1/2, that fractional exponent is really just the square root of x plus 2. It's just a different way to write this. So if it is written like this, which it might be, and it will be later on in this lesson, you still approach this the same way. So anything with the fractional exponent is your radical. We always want to isolate the radical, which it already is. It's alone on one side of the equal sign. So what do we do to cancel out a square root? We still square both sides. Now here, it's actually a little bit easier to see why the square root and the square cancel each other out. So if you look closely, we have a power of 1/2 raised to a power of 2. So if you remember our rules of exponents, anytime you have a power to a power, so x squared raised to the 3rd, you always are going to multiply those exponents together. So when you multiply 1/2 times 2, that's just going to equal 1. So anything to the first power is just itself. So that's why we're only left with what's underneath the radical. Make sure that when you square the other side, you FOIL. So it's x minus 4 times x minus 4, which is x squared minus 8x plus 16. We're going to have to factor this, so let's get everything on one side of the equal sign. So we have an x squared. When we subtract that x over, we're going to have negative 9x and plus 14. So two numbers that multiply to positive 14 but add up to a negative 9 is x minus 7 and x minus 2. So we're going to get x is equal to 7, excuse me. X is equal to 7 and x is equal to 2. So before we stop with this problem, make sure you check your answers. So from the original, I'm going to plug in 7. And I'm also going to plug in the 2, and we want to make sure that both of these work. Sometimes both work, sometimes they do not. So for when you plug in the 7, you get square root of 9 is equal to 7 minus 4 is 3. So does the square root of 9 equal 3? Yes, it does. So 7 works. And then we get the square root of 4 is equal to negative 2. The square root of 4 is positive 2, does not equal negative 2, which means negative 2 is an extraneous solution. So we're now going to add to this a little bit. So we, over the past few days, have introduced cubic roots or fourth roots or just radicals with different with a different index. We also, instead of writing it as a radical, we wrote radicals as fractional exponents. So that's really what's going to be new today, but the process is still the same. So looking at the first example, instead of a square root, we just have a cubic root. So what are we going to do to solve for x? Well, first step is to always isolate the radical. So we want to get the cubic root by itself. So we're going to move that 3 over. And to cancel out a cubic root, well, if we had a square root isolated, didn't we square both sides to cancel out the square root? So if we have a cubic root for both sides, we're just going to cube both sides, and that is what will cancel out the radical. So cubic root of 5x plus 2 cubed will just be 5x plus 2. 3 cubed is 27. We're going to solve for x. So we're going to get x is equal to 5. And as always, make sure you check your answers. So off to the side, we're going to plug in 5. So when we plug in 5, we have 5 times 5, which is 25 plus 2. So we have the cubic root of 27 minus 3 is equal to 0. Cubic root of 27 is 3. So 3 minus 3 is equal to 0. So 5 is a valid answer. So example 2 is actually very similar to example 1. We're still dealing with a cubic root. The only difference is instead of writing it as a radical, we're writing it as a fractional exponent. But it does not change how we approach this problem. Anything that has the fractional exponent is your radical. So make sure it's isolated. So in this case, it is. So we're going to then try to raise both sides to something that will cancel out the cubic root. So just like in example 1, what will cancel out a cubic root? Well, that will be a cube. The reason it's a cube is, remember, rules of exponents. If you take this 1/3 and multiply it by 3, because you have a power to a power, 1/3 times 3 is just 1, so you're just left with the 2x plus 1 is equal to negative 27. Solve for x. So we get x is negative 14, and just like normal, make sure you check. So when you check this, we're going to plug in 2 times negative 14, so that's negative 28. Plus 1 is negative 27 to the 1/3 is equal to -3. So you could use your calculator to help you with this if you're not really comfortable with fractional exponents on your own, but this is really just asking you to take the cubic root of -27. It means the same thing, which is -3. So -14 works. All right. So for example 3, we have an x to the 1/6. So x to the 1/6 is really just the 6th root of x. Okay, so the index of that radical is just 6 in this case. So just keep remembering anything that has the fractional exponent is what your radical is. So that's what you need to isolate. So we want to isolate that x to the 1/6. So we want to move that -2 over, or add that 2 over. Okay, so what will cancel? What should we raise both sides to cancel out that 6th root? So if we have a 6th root, we want to raise it to the 6th power. I'm not sure if you start to notice a pattern here, but when you are looking at what you are raising it to, when it's written as a fractional exponent, you're really just raising it to the reciprocal power. Reciprocal means flip. So 1/6, when you flip it, is just 6/1. And that's really what you're raising it to. And that will happen every time. If you notice in example 2, 1/3 raised it to the 3rd isn't 3 of the reciprocal of 1/3. So you could also think of it that way. So when we take x to the 1/6 and raise it to the 6th power, we're just left with x. 2 to the 6th power is 64. So we got that x is 64. Again, just make sure you check your answer. So we have 64 to the 1/6 power minus 2 has to equal 0. So this is the 6th root of 64 minus 2 is equal to 0, which is 2. So 2 minus 2 is equal to 0. That is true. So 64 works. All right, for example 4, it may look a little bit more complicated because we have a fractional exponent that's 4/3, but we're still going to approach this the same way. So anything with the fractional exponent is the radical that needs to be isolated. So the goal is to get x to the 4/3 by itself. So the first thing I'm going to do is add the 2 over. So we get 2x to the 4/3 is equal to 162. And then divide the 2 in front of this x over. Notice it's just the x that's being raised to the 4/3, not the 2 as well. So that's why we can divide that 2 over. So we get x to the 4/3 is equal to 81. So I want you to now think of what I was talking about in example 2 and example 3, that when you have a fractional exponent, when you want to cancel it out, you are actually raising both sides to the reciprocal power. So think about, what can I multiply 4/3 by to get it to equal 1? So in order to do that, we're going to raise it to the reciprocal power, which is the flipped fraction. When you multiply 4/3 times 3/4, that's going to equal 1. So that will cancel out that fractional exponent, and we're just going to be left with x. And then we're going to be left with 81 to the 3/4. Now, you could always type this into your calculator if you want, but think about what it means to be a fractional exponent. The denominator is the index of the radical. So we're really taking the 4th root of 81, and the numerator of that fraction is the power, and then we're raising it to the 3rd power. So the 4th root of 81 is 3, and then we're going to cube it, so we get x is equal to 27. As always, make sure you check your answers. So we're going to have 2 times 27 to the 4/3 minus 2 has to equal 160. So 27 to the 4/3, is really the cubic root of 27. So if you want me to write this out for you, it's the cubic root of 27 raised to the fourth. Cubic root of 27 is 3. 3 to the fourth is 81. So we have 2 times 81 minus 2 is equal to 160. So we have 162 minus 2 is equal to 160, which works. So 27 is your answer. Why don't you pause the video right now and try example 5 on your own and see how it goes. Okay, so hopefully you took some time to try example 5 on your own. So the first step, I'm just going to walk through it really quick. You can see the solution here. It's also on the key that's posted. But you're going to isolate the radical. So the radical is anything with a fractional exponent. So I isolated the 2x plus 7 to the 1/2. And then I'm going to square both sides because you want to raise both sides to the reciprocal power for that fraction in order to cancel it out. So I end up with 2x plus 7, and please remember to FOIL this. So when you have 2 plus x quantity squared, it's 2 plus x times 2 plus x. So when you FOIL it out, you get 4 plus 4x plus x squared. Then you're going to have a quadratic that you're going to solve. You do get -3 and 1, but when you check your answers, 1 is the only solution that works. Example 6 is slightly different than the problems that we've been doing on the first page. We have 2 radicals here. We have 2x plus 1 to the 1/2, which is a square root. And we have 3x plus 4 to the 1/4, which is a fourth root. So we have 2 different types of radicals in the same problem. We're still going to start this the same way. I want to isolate one of the radicals. It does not matter which one you do. I'm going to choose to keep the 2x plus 1 to the 1/2 on the left side and move the 3x plus 4 to the 1/4 to the other side. Now the nice thing about this problem is that when you do this, both of the radicals end up being isolated. But now we have to figure out what are we going to raise both sides to cancel out these radicals. Now ideally, you only want to do this step once. So I just want to show you what you really have to think about. So a lot of people will say, okay, well, this is a square root. If I want to get rid of a square root, I'm going to square both sides. So I'm going to square both sides. So the square root's going to cancel, so we end up with 2x plus 1 to the first power, because the 1/2 and the 2, when you multiply them together, it's just 1. But when you multiply the 1/4 and the 2 together, we're still left with a fractional exponent. So 1/4 times 2 is 1/2. So do you see how we still have a fractional exponent, which means we still have a square root in this problem that we, again, need to get rid of. Now, what can you do from here? Well, can't you square both sides again? Won't you get rid of that square root? So the 3x plus 4 to the 1/2 squared again will cancel. And then we have 2x plus 1 squared, which we have to FOIL. This is a valid way to do this. But if you want to do this in one shot, you can approach this a little bit differently. So if we have our 2x plus 1 to the 1/2 is equal to 3x plus 4 to the 1/4. If you don't want to have to square this multiple times, think about what number can we raise both sides to cancel out both of the fractions at once. So instead of, we chose to square both sides in the first way that we did it. But if you raise both sides to the 4th power, then these radicals will cancel out right away. So if you do 1/2 times 4, you end up with 2x plus 1 squared. So see how it's no longer fractional. And when we have 1/4 to the 4th power, we're just left with the 3x plus 4. So we end up in the same exact spot no matter which way you choose. So I always try to do it in the shortest amount of steps. So I would always try to look at what number, when you raise both sides to it, will cancel out both of those fractions. It's usually the common denominator between the two fractions can be helpful. So in this case, the common denominator was 4 between 1/2 and 1/4. So that's why I raised both sides to the 4th. But again, it does not matter how you choose because to start this problem, because you end up in the same spot no matter what you do. So now from here, remember we're going to FOIL the 2x plus 1 quantity squared. So that's going to be 4x squared plus 4x plus 1 is equal to 3x plus 4. So we're going to have to factor. So let's move everything over so it's equal to 0. So 4x squared plus x minus 3 is equal to 0. At this point, in order to factor this, because there is a 4 in front of that x squared that you cannot, and it's not a GCF that you can take out, you will have to split the middle term. I'm hoping that at this point we are more comfortable with the process of splitting the middle term. I'm not going to go over it here, but if you do have questions on splitting the middle term, be sure to ask your teacher. I'm sure they would be happy to go through it. So when you factor this, you're going to get 4x minus 3 times x plus 1 is equal to 0. So we get x is equal to 3/4, x is equal to -1. Make sure you check your answers. So when you check and when you plug in, let's see, if we plug in our 3/4, so we have 2 times 3/4 plus 1 to the 1/2 minus 3 times 3/4 plus 4 to the 1/4. When you simplify this, we want it to equal 0. 3/4 will work. When you plug in the -1, that one will not work. So that one's going to be the extraneous solution. All right, so why don't you pause the video and try the next 2 examples and see how you do, and then you can restart this video once you're ready to go over those examples. So for example 7, we want to first isolate the radical. So the radical is what has the fractional exponent, so I'm going to divide by 3 to isolate that. So we have x plus 3 to the 3/4 is equal to 27. Now this is one of these problems where you want to cancel out the 3/4, so you want to raise both sides to the reciprocal power to cancel this out. So 3/4 times 4/3 is going to be 1, so you're only left with an x plus 3 is equal to 27 to the 4/3. So when you simplify this, this is saying to take the cubic root of 27 and then raise it to the 4th power. So we get x plus 3 is equal to, the cubic root of 27 is 3. 3 to the 4th is 81. So when you isolate x, you're going to get 78. As always, make sure you check. So to check, plug in 78 to the original and make sure it works. And in this case, it does. All right. right, and on to the last example. Don't let this one scare you too much. It actually looks a little worse than it is. So, the first thing that you want to do is make sure that the radicals are isolated. So anything with a fractional exponent is our radical. We want to make sure that they're alone on one side of the equal sign. And in this case, both of these radicals are already isolated. So we don't have to do anything to isolate either of these. So now we have to work on canceling out the fractional exponents. Now we have a 2/3 and we have a 1/3. We want to cancel out the fraction. It's the number in the denominator that's causing this to be a radical, and we want the radical to cancel. So what are we going to raise both sides to cancel out the fraction? So 2/3, we want to raise it to something so that we no longer have a fraction. We really want to cancel out the denominator. And then same thing with the 1/3. Since the denominators are both 3, if you multiply both of these fractions by a 3, then those denominators will cancel. So we're going to be left with 4x plus 3 squared, because 2/3 times 3 is 2, is equal to 16x plus 44. 1/3 times 3 is just 1, so you have 16x plus 44 to the first power, which is just 16x plus 44. And then this is just a very straightforward algebra problem that you have to FOIL on the left side and then solve for x. So when you FOIL 4x plus 3, we get 16x squared plus 24x plus 9 is equal to 16x plus 44. We're going to have to factor because we have an x squared, so let's get this equal to 0. So we're going to have 16x squared minus 8x minus 35 is equal to 0. Again, this is a problem where you're going to have to split the middle term. So be sure to ask your teacher if you need to go over how to do that. When you split the middle term, you should get that this factors to 4x minus 5 and 4x plus 7. So x is equal to 5 over 4 and negative 7 over 4. Make sure you check these answers, and when you do, you'll actually find that both of them work.